Okay, great. So for those of you maybe I haven't met or don't know, my name is Brian Gardner and I'm Technical Director at IC Blue in Leeds, based company. So we're the component distributors and also the EDA vendors for the Mentor Graphics tools. We're going to focus on today the topic of automating electrical sign-off. So we're just going to maybe go through a little bit of an agenda as to what's going to take place today, and then we will have a demonstration as well. So really, what's involved in meeting the compliance requirements for PCB? What are the challenges that you're facing at the moment? What is sign-off, and what does it mean really to automate the electrical sign-off? Is there a solution out there? Well, we believe that there is a very good solution, and we're going to show it to you today. We're going to do that by way of demo as well. And then we're going to come back to this slide deck and just show you some configurations. There's not many slides. There's probably less than 10 actual slides that we will go through. So it's really going to be more based on the demo side of things and showing you what the tool can actually do. So really, there's probably no need for me to remind you guys or to tell you guys how you're doing your job or the challenges that you're facing on an everyday basis. Whether it's things along the lines of EMC guidelines or EMI guidelines that you have to try and follow. If you're in the realm of doing mixed technology boards, well then you're going to have other things, maybe safety requirements, could possibly be national standards you have to follow, or even international standards for some of your products or for your designs. So all of these things, the EMC, the safety, it goes into then maybe the PCB design guidelines for the IC from the IC vendors themselves. All of these things are really a challenge for you to be able to implement within the board. You've also got standard design, standard buses, but many maybe variations on those. We have PCI Express, maybe generation 1, 2, 3, or 4. We've got USB 3.0 and 3.1, HDMI, and of course, what's in a lot of boards, a lot of designs that I'm seeing these days, especially talking to customers, are the DDR side of things. So DDR3, DDR4, and possibly even going on to DDR5. So all of these things have to be considered in order for issues really not to arise within the board as you're doing the design, but most importantly that it doesn't affect the actual function or even the integrity of the design once it's been manufactured. And really, it's no small task. We really do acknowledge that there's a lot to be said for what goes into PCB design these days. And the thing is, it's only getting more complex. So really what we're looking for is maybe a way to alleviate some of that pressure. How is it currently approached? The design guidelines, it's possibly done as we would describe it the hard way. It's really the interpretation of those guidelines by the designer himself. And he needs to be flexible then as well to see, well, where can he maybe deviate from some of the recommendations? Where can he be flexible in the implementation of the design itself? But as the board is designed then, it needs to be checked. So how is that normally done? Well, usually what we talk to customers, it's a lot of visual inspection is done. I think the graphic maybe paints a good picture of how you feel when you have to do this visual inspection. But really, how accurate is this type of checking? Well, it's error prone, isn't it? There's many things that could be overlooked. Maybe we're unsure of what the actual requirements are, so we're not sure of what we're looking for. Or maybe it's just maybe a lack of expertise in particular areas that maybe face our design teams. Other things are, well, how long does that take? Well, visual inspection of maybe a complex board, it could take hours, it could take days, it could take even longer maybe than days, could take even weeks to really go through and thoroughly check the board. And the other challenge is then, well, how often can you do that? Well, how can you go and do visual inspection every single time something changes? Well, what we tend to see is it's done maybe once towards the end of the design, that some visual inspection is done on these particular maybe problem areas that you might be finding. And then again, there's the challenge of who can check it. Well, it goes on to maybe signal integrity or power integrity, maybe an EMI expert that would need to give of his time in order to be able to spot these things and maybe pass them back for correction. And well, is it possible to maybe get some of that expertise, be able to learn some of that? Well, it is, but it's difficult, and it's not really productive, because it really takes a lot of time sometimes for maybe even the PCB designer or the engineer involved in that PCB design to get up to speed with what those requirements are. So when we say that we want to get the board to sign off, what are we talking about? Well, we're really looking for a process of verification, as it says, that the design must complete in order for it to be manufactured. And this is something that's common to the IC space for a number of years, but it is also increasingly becoming more common name, or common, should we say, phrase within the PCB domain as well. So that's what we're really looking for. But what is the problem? What's the issue that's faced? Well, there seems to be a huge bottleneck when it comes to maybe the sign-off of PCBs. Maybe the first instance, as we see along the top, what if something changes along the way in the design? Well, then that maybe have to result in multiple visual inspections before it can even get to that EMI or EMC SI or PI expert for him to view, what those changes and how they impact the design. Or maybe it's the second section there. Maybe you're actually working in a large group, and the resource, the time requirement for these experts, or for these particular ones with skills in these areas, well, it's quite demanding if there's multiple designers looking for their time and their know-how on this. So what needs to happen? Well, what really needs to happen is we need to be able to automate the electrical sign-off to some degree, at least. And what you're looking at here is a paradigm shift, really, from left to right, or from right to left even, of the expert. So what you're looking for is a way to be able to encapsulate and to be able to give out this knowledge to maybe users that can use this and maybe do some of this checking themselves. What you're doing by doing that is you're removing that bottleneck by capturing some of the expertise from the maybe high-speed expert and putting it in the hands of the designers, giving it to them to be able to use this information and be able to check the board rather than create this bottleneck. What you really want, though, is to be able to use reliable and reusable and also repeatable set of rules that you can run across your designs and that you can be confident in. You can even, maybe, is it possible to go one step further and even customize and create your own rules? So, could we go to that level as well? That would be great to be able to do. What it also does is it gives the designers the ability to be able to implement this checking and this sign-off. And where that helps is it's not leaving things right to the end where a process is run, maybe as the design is, as they would consider completed or nearly completed. These checks can be run at any time during the design process, and really that's going to help with the reliability. Is going to help with the better outcome for that product in the end of the day. What it will also do, if we're able to have something like this, is improve the coverage of the checks within the board. So maybe at this time there's only a small percentage of the board that goes maybe to that expert to get sign off on. Well, if there's tools and there's rules you can use that can be run on the whole board, well, then that would be a huge advantage. You'll be able to cover more to get a full picture of any other potential issues that might be happening around the board. So that's just highlighted here with some of the objects that we might want to check and maybe don't have time to do, maybe 100% of the time. So nets, crossing gaps, I/O coupling, diff pairs, or your crosstalk. Can we set up rules, or is there something that we can use that can apply rules to the physical design that we've created in order to spot maybe some potential issues or potential areas that need to be fixed? Well, there is a way, and Mentor have released it. It's not very new to the market. It has been around for a little while, but introducing really Hyperlinks DRC. It's an automatic electrical sign-off process that allows you to be able to gain back huge amounts of time when it comes to maybe the visual aspect of checking for complex issues on your board. And it's a rule-based approach rather than maybe the traditional simulation approach. So what we're looking at is creating rules that can check against physical objects that have been placed in the PCB and maybe looking for areas that could be a potential issue. Rather than having to traditionally go off and spend the time simulating these, well, are there certain common things that can be picked up, and maybe then it can go to simulation if it does require that. There are a standard set of checks out of the box with Hyperlinks DRC. There are checks for EMI, so things like traces, crossing splits. We've got via stub lengths that we may want to be checking. For signal integrity side of things, we've got maybe checking for long nets, maybe checking for the termination on particular nets to make sure it's accurate, it's correct. Or maybe on the power integrity side of things, we want to check, well, do we have enough copper going to that particular IC? Do we have the net width that's required in order to be able to feed that component? Or maybe do we have our decoupling capacitors in the right place? Are they placed close enough to the power pins that are required? And all these, along with more, we'll highlight some of the other rules a little bit later on and what the capabilities are. But all of these are visual results, so they're not just lists of errors. So you can visualize where these things are happening on the board and actually be fully integrated with Power PCB, with PADS PCB as well. What's the advantage then? What's the benefits? Well, they're fairly immediate. They're going to reduce the time it's going to take to get your design completed. It's going to obviously accelerate that sign-off process and also increase the users that are capable of being able to be involved in this sign-off process too. So we're not just relying on the one specialized engineer. We're also, as we mentioned, improving the analysis coverage. So we're looking to eliminate errors that maybe from the manual inspection side of things and be able to give 100% coverage, as it were, to checks across the board and across complex boards. We don't have to just focus on one area. But that's going to help us with maybe reduced failures when that product goes out into the field, things that we haven't spotted before it went to manufacture. And it'll also alleviate this bottleneck or this problem of time that it takes to do this electrical sign-off on our boards. Of course, it does other things then. It will, in doing that, have knock-on effects for the cost of being able to produce the boards. We'll go down to the amount of respins possibly that we're doing for our boards, or any scheduled delays that we're facing. So that's just a very quick overview of the tool itself. What we're going to do now is just go into a demo, and then we'll come back to the slide deck and give you some of the information on the configurations for this. So I'm just going to launch PADS PCB design software in this instance. I'm just going to pick a demo design, and bring it into Hyperlinks DRC and run some checking on it, and really show you how quickly and how easy it is to do this. Now, it's in this instance we're launching it from within PADS, but the tool itself is vendor independent. It's not specifically a Mentor tool in that it only works with Mentor products. It certainly works with all other PCB design tools out there. Been able to support ODB++, been able to support IPC 2581. So if it's a case that you're not using PADS and you want to be able to use this Hyperlinks DRC tool, well, that's fully possible. So we're just going to flood the planes on this particular design, and we're just going to then go to Tools. We're going to go to Analysis, and we're going to push it over into Hyperlinks DRC. So the direct connection between the two writes out what's called a CCZ file, so that will open up within Hyperlinks DRC. So here's what it looks like when it first opens up Hyperlinks DRC. What you will find is the first time you open it up is that it will present you with a wizard. So the wizard is actually extremely useful. It helps you to be able to see what your project setup, how to be able to step through the steps if you're new to this, how to be able to set up the board, set up your preferences, your options. So as you can see, if we click next here, we'll step down through the Project Explorer on the left hand side here and ask you to fill in the things that you need to be working in, maybe your type of units, your default settings, your project paths that you want to set, including maybe local paths to either IBIS models or local model directories. And so that's a nice, easy way to get started with the tool. You're not just left on your own to try and figure everything out. You can step through the wizard, and it will get you the settings, at least, that you need to be working with. So just click finish on that for now, close off the wizard. And really the first I guess window that you're presented with, it's within this number of windows, you're got the capability of not only to set up the project, you can also verify the design that has been imported. You can configure some rules. You can then run those rules, and then you can interpret any rule violations. And again, with any of these tools, if you don't like the way it's set up, you can choose to change the window locations or move things around the way you want them. Just simply by double clicking on the banner of that window, we'll free it up, and then you can place that wherever you'd like to put it. So across the top, there's some very useful tools. There's just a couple to mention. Obviously, our navigation around the tool can be done here through our zooming commands. We have then moving on to the dim mode. The dim mode is fantastic for basically dimming everything else out except for what you've highlighted. So if in a dim mode, and over here in the selection toolbar, we have components selected. It just means that when I select on a particular component, everything else is dim, and it really highlights that. And that's the same for maybe nets that we're tracing through the board, visibility that we want to be able to see things on the board. We've also got an ability to be able to switch on and off a grid here. If we like working with the grid spacing that's there, maybe not, we can switch that off. We've got capabilities for measuring, so we can measure distances within Hyperlinks DRC. And then, as we said, over to the left or to the right hand side here, we have a selection toolbar where we can narrow down what it is we want to select. So maybe we don't want to select components, but we do want to select maybe nets on the board. Well, we can go ahead and do that and select and highlight particular nets. So just looking at the Project Explorer, just to give you an overview, I guess a little tutorial on how this works, a little breakdown of how this works. You'll see in the Project Explorer that it's broken down into 3 areas: the project data, the analysis setup, and the rules and the results. Well, the project data is really the information that's just been loaded from, in this instance, PADS layout. But here we can see the layer information that's come across. It will take the layer stack up information from PADS and bring that into Hyperlinks DRC. It also brings over all the component information that we can sort. So we could here obviously list things by reference designator. We could also right mouse button here and maybe group things by the component type if we prefer to do it that way. And you can see now when we go back into the components that all of our capacitors, connectors, diodes, they're all grouped to their like components. So again, it does the same with electrical information, electrical nets, physical nets, even the net classes that we have set up from PADS, these rules that have come across from PADS, and any constraint classes as well as differential pairs, all get recognized and brought over into Hyperlinks DRC. So that's the project data, and really that's information you can verify that it's correct. So what we could do here is maybe see, well, how does it know that all of the capacitors are, beginning, or how does it know how to look for these? Well, we can navigate into this. We can change some of the behavior as to how it recognizes capacitors, how it recognizes diodes, things like that. So if we just look at the analysis setup, we can see here anything to do with again, the information that's been brought across from PADS is listed in here in 2 different things, in the system objects list and also in the user objects list. So again, we can look at how does it recognize maybe some system objects, how does it recognize capacitors? Well, if we select on capacitors, we can see that down in the properties window here, we see that there's some presumptions here that the value, the reference designator starts with C and the pin count is equal to 2. So really this is just, again, been able to create some object lists which you can later use to be able to run specific rules on. It just breaks down the design into really intelligent blocks for you to be able to use. You'll notice that the system objects, we can't add any system objects. What we can do, these are predefined, but we can, as we said, change any of the parameters about those, but we can't add to the system objects list. But we can add to the object, the user's object list. And here we can start to add our own object lists. As you can see, if we right mouse button, we can now create some new lists here. But you'll recognize that it also it identifies some particular objects that may be of interest to us on the board that's come across. And maybe just for instance, if we look at radiation high, again, we can change some of the parameters here, but if we look down in the properties, we see that it's looking for any clock nets on the board. Okay, so if we extend that and look at some of the electrical nets, again, we can see that the clock nets have all been assigned automatically. I've not had to do this as that board has come across. So I can then start running rules a little bit later and applying them to maybe some of these object lists. What I'm just going to do in this case is create a new object list, just to show you how quickly and easily that's done. So we're just going to create a new list, and we're going to call it _DDR in this case. Just hit return. The only reason we use underscore is really just to filter it so it goes to the bottom of the list, the underscore property there. And what we're doing here then is we're looking at maybe applying what are the objects, what are the properties, what's the scope, what are the parameters that we're going to be able to use for DDR. So I could put a description here in this case, or what I could do is just go to the object type. I could say that it's DDR electrical nets is what I'm interested in. And I want to sort the contents. I could do this manually, or I could do this automatically. So manually, I could just scroll down through here and I can start selecting on nets and passing them over into becoming part of that object list. But what I'm interested in doing is looking at the auto setting here and just create a new condition. So the new condition, we need to choose a property. That property will be the name, and then the condition will be contains, and then let's just put in DDR and hit return. You'll notice straight away it's populated electrical nets, all of the DDR electrical nets that are available to me. So again, creating your own object lists, very easy. You can take existing object lists here, you can copy them, you can change the parameters, rename those. So that's it's quite easy to do. The third part of this Project Explorer, as we mentioned, is the actual rules and results. So here are the rules. The three areas in particular that Hyperlinks DRC covers: EMI rules. So if we expand those, we get to see what type of rules we can run. We can look at the signal integrity rules. Again, that's the power integrity. Look at the signal integrity rules that we can run. And also we can look at the power integrity rules that we can run. What we can also do, which I've done in this case, is create my own set of rules that I know I can run and I have the license to run. So I've created a PADS DRC rules section in here. So first thing I want to do is run maybe Metal Island. So let's go ahead and run Metal Island to check to see if there's any floating pieces of copper maybe that I've not picked up on within the design that may create some EMI issues. Again, clicking on Metal Island, looking down at the properties. Again, we have here the applied to. We could have a scope. We could point it at an object list, maybe just some particular nets. In this case, I'm just going to run it on the whole design and see what it comes back with. So if we right mouse button on Metal Island, hit execute, it runs through and tells me down in the output window that there are 11 violations found. Okay, that's interesting. What I want to do here then is look at the spreadsheet information, and you'll see under parameters, here's what it's measuring against. And again, this is a really lovely way of being able to understand what the rules are that are being checked. Very graphical, very easy to interact with and be able to change some of the properties. So here in this case, we see some of the values that it's looking to apply this verification check against. If I go to the violations section of the spreadsheet here and just select on maybe the first item here, okay, yeah, we can see that I've placed a trace right through this piece of copper and it's cut it off, and now that is a floating island that I might not have picked up on. Again, I have some here. I have some pieces of copper that have been maybe on an internal layer recognized as floating pieces of copper. Now, the nice thing if you are using PADS is that you can use the cross-probing facility. And that means then when we switch this on, that within PADS itself, it can highlight to me where that issue is and be able to show that to me. from directly within DRC. So again, if we click on the metal island, the first one, and if we look back in PADS layout, it automatically zooms to that and shows me here's the metal island. I can go ahead and correct that if I wanted to. Okay. So another thing I might want to check, again, if we look here, we can see the violations, the last run violations. We can also see that we can run a selection of violations, and we can compare the last run against the previous run of violations. So we can see as we're improving what's been corrected. But in this case, I'm just going to delete the violations, in that case, from Metal Island, and I'm going to run next the nets crossing gaps. So this one is one that I remember particularly in doing PCB design, taking quite a long time to try and find where do we have some nets, that maybe high-speed nets or critical nets crossing either a gap in the reference plane or crossing over a plane where it shouldn't. And how do I locate those across a whole board? In this case, I think we're a 10 or 12 layer board in this instance. So again, what we're going to do is look at the nets crossing gaps. And we again come down to the scope, into the properties, come down to the scope and look at the object list. And in this case, it's looking at radiation high. So as we saw earlier, that was the clock nets, wasn't it, that it was running against. So okay, let's see what that looks like if we run what clock nets are running over gaps within my board. Okay, I see my output windows tell me I have 7 violations that have been found. Again, if I go to the spreadsheet view, I can again get a great view of what it is it's checking against, what are the properties that I'm entering down here that are going to result in the errors that are maybe being fed back to me. Things like what's the allowable gap. So it's right down at 1 mil at the moment. So could I increase that and maybe run it again? Well, yeah, certainly I could. Let's have a look at the violations. And again, what we have is the ability to be able to really hyperlink on those, click on any one of them, and be able to see where that particular net is crossing the gap that we may need to give some attention to. And so this is great information. Again, within the details settings down here, it tells us what the net is, it tells us what the layer it is, what the reference plane is, and what the gap is that it's crossing. So again, we can take note of all of those. But it's not really just for use within DRC. What we can do is create some really good reports from this. So maybe if we're reviewing somebody else's work, maybe we've outsourced some of our design and we want to run some rules and we want to feed that information back. We don't have control of the PCB. We want to just feed that information back. Well, what we can do is from the spreadsheet window, we can obviously save HTML files. We can save CSV files if there's a number, maybe a high number of errors. There we might want to sort those a little bit easier. Or what we can also do is create what's called a share list. In this case, I'm just going to create a share list here. I'm going to select these particular nets of interest that I want. And actually what I want to do here is, I'm just going to add those to my share list. So I just need to select the ones I'm interested in, add them to the share list. And what I could do here is I could put in some notes. I could put in maybe what the status is, whether it's critical, whether it needs to be fixed, whether to ignore it. I put in some notes maybe along with that. But just to show you what the information is that it generates, if we go to the project folder, and let's have a look at the file here under layout. And what we want to do here is then export this share list. And once we've done that, you'll see that the share list folder appears within the project location. And in this case, it saves all of the images, gives the share list XML. But really, if I was to open up this HTML, this is the type of information I can now generate to feed back to maybe the designer to maybe pay some attention to or maybe fix some of these issues. So again, a really nice way to be able to not only contain this information within Hyperlinks DRC, but to be able to really bring that out and share that with others. Okay, one last thing I might want to do is the via stub length. So maybe I'm interested in this case, again, an EMI issue. I'm going to run this not on the whole design. Again, we're going to come down to properties and choose an object from the object list. We're going to go with the DDR nets in this case. What I want to know is, are there any stubs on my stub lengths on my DDR nets? So specifically just looking in the DDR nets here. So we can execute that. And yes, of course, yeah, we can see, look, 48 violations found here. So we may want to look at some of the parameters. We may want to look at, why is this something we want to look at? What is it actually measuring? And what is the value that it's measuring? So maybe if we said we could allow up to 25 mil, what we can do is just rerun this. And we had 48, I believe, and now we're just down to 21 violations. And of course, we can look at those violations to see where on the board they appear. And again, over in the details window, what is the actual stub length that we're talking about here? So we're allowing 25, but we're actually up at 30.6 here for some of these, and possibly even more. Okay, so that's another of the EMI rules. What I'm just going to go on to is maybe some signal integrity rules, so maybe just some calculating some differential impedance, maybe again against the DDR nets. So let's select that one on, and let's select the object list to be the DDR nets. And we're just going to look first of all at what are the parameters that we're looking at here. And we're looking for a goal at the moment of 100 ohm target impedance for these nets. So let's see what the result is in this case. Again, what we can do, we could go to the next level, as we mentioned earlier, of assigning the actual models to get an extremely accurate picture of what's going on. That's very easy to do, to add those models to the components. So if we just execute this again and see what are some of the violations. So here it's highlighting to me some areas that really are not meeting the requirement of the 100 ohm impedance for this particular net, for these particular nets. So that might be something I want to maybe feedback as well, or maybe change the stack up information if that's not correct at this point in time. We can also look for things like long stubs. So are there any stubs on the design, on particularly maybe the DDR interface again? So let's pick the long stub rule here. Let's pick the object list to be, again, DDR. And let's just right mouse button and execute that rule. And yet my output window tells me I have found one violation. And again, I can navigate to that. I could choose to feed that information back, maybe to the PCB designer as well, by way of either a share file or maybe just pointing that out in a report to him to maybe correct these issues. A couple of the other things then they just want to cover on the power integrity side of things. Well, I might want to run maybe power and ground widths. I'm not 100% sure at the moment, do I have all of the correct power and ground widths that I require. So what I'm going to do is run the power and ground width against my ground nets. If I look at the parameters for this, I have some values in here that I'm checking against. So I'm looking for a minimum width of 20, and on any internal layers, a minimum width of 10. So let's run that on the ground nets. Again, the ground nets can be set up to contain really anything we want, but we have it containing a bunch of power and ground nets at this time. So let's go into the violations and let's have a look at, yeah, some of these here. We can see that really they're well below what we're expecting. Maybe some of them are okay. Maybe some other nets that are either power or ground nets may need to be increased depending on what those nets are. And so really this is just a very brief overview to show you maybe Metal Island. How do you check that? You know, that's a visual check most of the time. Okay, some tools are able to remove those things, but again, it's good to be able to run these just to make sure that we're not missing anything, or that we're getting 100% of the board checked for any of these issues. We looked at nets crossing gaps, again a very visual one, to be able to to spend the time looking for all of those within your design can take quite a long time. Stub lengths, checking differential impedance across maybe a bunch of nets, particular sensitive nets that we're interested in, looking for stubs on lengths of nets. That again would be a problem if that fell through. And also then maybe power and ground, maybe checking to see, do we have enough copper in these areas, especially for power to be feeding some of our ICs. So again, some visual checks have been very easily automated, as we saw, can be written out very nicely in reports, and can be fed back to the PCB designer. So that just brings us back then to our presentation, just to give you a little bit more information about the tool itself. So it comes in a number of configurations, and I think you'll notice that the first one is free. So basically there's a free version that contains 8 rules that you could download from the mentor.com website right at this point in time. There are there's an e-commerce website there where you can purchase a gold version, which contains 22 basic error checks, and also the standard 32, or even the developer license. So like we spoke earlier, being able to develop your own rules, be able to write your own scripts, to be able to write those custom rules for your designs. That license is available. So the supported formats, as we said, really it's an independent tool, so it doesn't really matter what PCB design tool you're using. Even if it can output an ODB++ or an IPC 2581 file, that's enough for it to be able to be run in Hyperlinks DRC. And to give you maybe a little bit of an idea of what those rules are, particularly the free rules here as we're looking at them. So we have the impedance checking is available under signal integrity checks. We have topology T-fork for DDR rule types. We have also flyby topology that can be checked for no, actually that one isn't there, but differential impedance is for diff pairs. Diff pairs, phase matching also within the free version. For power integrity, the decoupling cap placement is there, and also for the EMI checks, the metal island and net crossing gaps. So they're all covered within the free version that you can download from Mentor. And then you can upgrade to some additional rules with the gold license, again containing 16 signal integrities, DRC checks, 3 power integrity, and 3 EMI DRC checks. And as we said earlier, we can then extend that even further. If you need more rules, if you need more functionality, more capability to be able to run these DRC checks, we can go to the standard license, or possibly even the developer license for writing your own custom rules. So that brings the presentation to a close. I'll be happy to answer any questions that anyone has. If you have, please maybe type them into the chat window if there's any questions that have come from that, or if there's anything else you would like to see.